Hello everybody and welcome to my channel Climate Change Solutions with Clemens. Today I would like to present you an idea that could have an enormous impact on the path of climate change. Um, I'm always presenting videos combining business and the protection of environments. So today I want to talk about the idea of the desalination plastic film in combination with the drought protection plastic film. And beforehand, I would like to say that this video is again sponsored by the very economic international business directory b2bpricelists.com. You can find the link below the video, and the directory offers a 50% discount rate for green tech startups. So let me begin with the idea of the seawater desalination plastic film that is at the same time producing solar power. So in our case here, plastic really is useful for the environment for a change, and the desalination film really could make a very big difference in countries that are suffering of high water scarcity all over the world. Yeah, Africa, Arabia, America, North America, South America, Australia, but as well in more northern European countries, where the climate is getting more and more warm and more dry. Today there are basically two ways of desalination. First is the thermal way, which is basically boiling water until the water evaporates and condenses again as fresh water. The other way is the reverse osmosis, which is basically pressing salt water with very high pressure through a membrane. And there are many factories of desalination using the process of reverse osmosis. However, we have the disadvantage there that these plants are complex to build and to maintain. They are highly energy intensive and therefore expensive and have a limited capacity. So there's, for example, a desalination plant in San Diego, USA, where the cost per liter is twice the cost of imported water. And it's up to 25 times as energy intensive as other freshwater approaches. So therefore, I would like to promote another approach, which is the simple two-layer desalination plastic film plus a drought protection plastic film that could really change the way of producing fresh water for many countries. It's not complex at all. It is very cost effective, and it really could be applied on a very big scale, literally transforming deserts into jungles or agricultural areas where exotic fruits or whatever fruits could be cultivated. So this could really change the climate on Earth, and for one of the very few times plastic could be very, very useful here for the environment. So how does this desalination plastic film look like? So I can show you a few pictures that I have created with AI solutions that help me to visualize this idea. So let me just quickly open these pictures. So let me show you these pictures. First, we have a possible way the desalination film could look like. Actually, it is two-layered, as you can see. Above, we have a transparent plastic film, and on the floor we have a black plastic film, which of course gets very hot when the sun shines on it and helps with the evaporation of the fresh water and leaving the salt back on the floor for later recovery either manually or automatically. Of course, this picture looks like a greenhouse, and it is quite short. I want to have it, go endlessly in the background until the horizon, but the AI didn't understand me quite. As I said, it's basically like a kind of greenhouse. So what you can see is the transparent roof, and this roof could be equipped with photovoltaic, not modules, but printed layers. So there is a technique which is applied by the company ASCA in Germany. They have a website which is asca.com, and they are able to print photovoltaic, organic photovoltaic onto plastic. They do this in a roll-to-roll process, so they can print many square meters in very little time. And this is how the roof could be equipped with either transparent or having a certain color. However, the more transparent, the better, as more sunlight can enter and heat the floor, where the desalination process then can be more effective. So as you can see, this is quite a short version, and I would have preferred that you could really see how long it is. This is an example, a better example. Let me make this big here. So seen from outside, that's how it could look like. You can see this is a round version. Yeah, it could be a round, of course. It doesn't matter at all. Where you have here the transparent film, the roof, and below the black floor. I think one can imagine, and the desalination film is to be used in combination with the drought protection film, which here only we can see a few meters, but as the AI didn't really get what I wanted, I tried and kind of succeeded with that one. So here you have the the image where you have the desalination foil like a tube, and to the left and to the right you have the plastic drought protection film, which is covering the ground, and below the fresh water is applied to the ground via drip irrigation. So let me check if I have further images regarding that. So this could be how it looks like. Of course, the tube could be much broader. Material is saved, and to the left and to the right you have the drought protection film. The drought protection film is basically just a plastic film that doesn't let the water evaporate into the atmosphere. So how does this drought protection film look like? In countries where you have no rain, it could be just a film without any perforation, any holes. However, it would make so much sense if you would print the solar generating layer onto this film as well, as I just mentioned, in order to have great potential to produce solar energy. Of course, if you imagine, if you have square kilometers of this foil on the ground, protecting on the one hand the soil, that the water does not evaporate into the atmosphere, and on the other hand you have a solar power layer printed on, you could produce so much electricity at the same time. So it has two advantages that are definitely worth exploiting. So in other countries where you have rain from time to time, for example, northern countries, Italy, Germany, of course you want to make use of the rain falling out of the sky as well, in order to not have to irrigate so much from below. So in these countries it makes sense that the foils will have a certain perforation, small holes, but holes that still do not allow that the water from below evaporates into the atmosphere. So you have here a little protective lid made of textile that reduces the exchange of air from below the foil outside. But you have below, you have of course small perforation, and so that the water can pass through the textile, through the little microscopic hole in the film, into the soil. So this is how it could look like in the northern countries, and of course again printed with a solar energy producing layer. Really, this could really solve two of the major problems of our times. It could generate all the energy needed, and at the same time reduce the effects of hot, dry climate, and therefore, the drought of our soils. All right. Regarding the solar cells that the company ASCA or ASCA is able to print onto various types of materials. Here I've got some samples for you. As you can see, it's printed on plastic foil and it's foldable, and even with just little light it already produces energy. Here you can see where you can plug in your cables basically. And yeah, these are two other samples of this type. And if we go to their website, I can show you some buildings that they have equipped with their print on solar panels. So here we are on the start page. As you can see, a beautiful building. Here they've got various projects, small applications, larger ones, and really beautiful way. And of course, very energy efficient and very economic because of the printing technology. And here you can see again the samples that I just showed you. So really a very good combination with the desalination plastic film and the drought protection plastic film. These two technologies combined could really produce all the energy that is needed on the planet, basically, if applied on a large scale. And as mentioned before, the combination between the desalination plastic film and the drought protection plastic film is very important, because the drought protection film and the drip irrigation below the drought protection film, with this we can grow jungle. We can grow any agricultural fruit or vegetable desired. For example, mangoes, pineapples, oranges, tomatoes, potatoes, corn, anything people love to eat and need as food. So the drought protection foil ensures that the water stays with the plants and with the soil. So let's have a look at the website of the drought protection foil, where the functioning and the design is quickly explained. So as you can see, this is the website. You see manufacturers and licensees are wanted. So if we scroll a bit further down, we can see a nice picture explaining the look and the functioning of the foil. As you can see, we have here like funnel shaped depressions, and we have the so-called water passage chambers that are at the same time sealing off the air and are absorbent to water, so the water can pass through from above to the soil, but it doesn't evaporate back from the soil into the atmosphere. So this is the design for countries where you actually have rain from time to time. In desert areas, these water passage chambers wouldn't be necessary. I already showed you the sample, which is even simpler at this part. It just has a textile ceiling above and a few holes below, so the water can drip off here and yeah, it's really easy and simple design. So for the countries that are still have rain and want to make use of that rain, this is a example of how the drought protection foils or films could be placed around a farm, for example, in the northern countries, without the combination of the desalination film here. But of course, both will be possible. But if you're really far inside a country and you still want to make use of the drought protection foil, you can simply apply it without the desalination plastic foil or film. And you can see as well, this film is equipped with a solar layer or organic solar layer. It doesn't matter if it's printed on top or if it's coated. Anyhow, it's just important that it's there. So yeah, and here you get all the further information and advantages regarding the drought protection film here. Again, I made a little AI example picture showing what it could look like if you grow all these wonderful fruits below a drought protection foil, and you have people working there and collecting the fruits. So I'll show you here. Yeah, really nice AI creation. It didn't allow me to here enlarge the green foil until the horizon for some reason, but you can see it would look beautiful if we would have this kind of vegetation instead of a desert in the very dry countries of Africa, Arabia, Australia, Asia, North America, South America. So it could look like that instead of a desert. What it could look like, so that we have a picture in mind. I got a small map here showing the African continent with this great area that basically consists of desert as well in Arabia here. Wouldn't it be so great if we could paint this part green as well with agricultural fields or jungle or whatever comes to your mind. So basically how it will work, if we applied the desalination films, like you can imagine, they would be like rivers. You have already the river Nile in this place, flowing from inside the country outside, with the desalination film transporting seawater into the country. You would have like rivers flowing from the sea inside the country. Of course, the seawater, would have to be pumped. But the pumping would be managed, or the energy for the pumping would come from the solar energy produced by the solar layers, the photovoltaic or organic photovoltaic layers in the foils itself. So you would have a huge surface on the desalination films and the drought protection films that produce much, much more energy, electric energy, than is needed for the pumping. You could export even this energy surplus. So what it could look like, if we apply the desalination films to the country. For example, we could start here. It flows inside the country. It flows inside the country everywhere. From the coast, inside the country. Everywhere. So, and at the same time, we apply the drought protection foil to the left and to the right of the desalination film. So you would have these areas becoming green. So, to the right and to the left of each desalination film river flowing inside the country. So everywhere, even to remote locations inside the country. So, more here, more there, here as well. So that's a start. Later on, it could be everywhere, the whole desert could become green as well here. In the Arabian countries, we could have rivers flowing inward the country. And in the land of the sheikhs, we could have jungle everywhere. As well in the US, United States, California, same thing. We can have rivers flowing inward the country, delivering water to all the dry places. Here in San Diego, we even have a seawater desalination plant. However, of course, with our desalination plastic film, it would be much cheaper to deliver fresh water to all the places where it is desired. Same is true for Australia, South America, Asia, everywhere. So to summarize again all the advantages of the seawater desalination film in combination with the drought protection film, we would have sweet water at the very low cost, converting entire deserts all over the world into green landscapes in Africa, Arabia, Asia, South, North America, as well in Europe. Additionally, there would be an enormous amount of green energy produced even for exporting. At the same time, we would create many low-tech and high-tech jobs. For example, in Africa, so many jobs in total, which is so necessary for people in poorer countries, which would even make migration obsolete. We could grow exotic fruits in these countries, making it much more easier to transport them to Europe instead of importing them from South America, which is a very long distance. And as you all know, big ships are polluting the environment at great extent. So a further additional usage of the seawater could be with saltwater batteries. So we haven't talked about this yet, but as you might know, if you have salt water and sweet water separated by a membrane, you can create an electric charge, as the charges of the two types of water are different. So you would have a current flowing. And this could be another application alongside the river flowing inward the country. So, for example, at night, you could still produce electric energy via the salt water batteries. So, if you might already know something similar like these two plastic films on the market, or a similar invention which is giving the same results, please let me know. Or if you have further ideas regarding the seawater desalination plastic film or the drought protection plastic film, please write them in the comments. I would be very happy to discuss them in the next video. Or maybe you know a firm or company producing plastic films that could be interested in starting the production, or governments or NGOs which are looking for exactly such a project. Please let me know. So that's all for today. Please share, like, and subscribe for more positive ideas and videos on the human potential regarding living in harmony with our natural environment. Just one last thing. Here, I got a book that I wrote a couple of years ago, and it contains another idea of how we could basically put the renewable energy production in the hands of every private person. So not only people who can put photovoltaic cells on the rooftop because they have one, but as well for people who live in apartment blocks and do not have their own home, how they can produce renewable energy on so-called solar fields organized by the district they live in. That's basically the idea. So you can find it on Amazon. I would be happy if you like it. Please write me comments on that as well. Greatly appreciate it. And yeah, thanks for today. See you in the next video. Bye bye.